So, in this lesson, we're looking at lung capacities, and it's focused on the idea of how much air is in your lungs at any point in time. Some of these things can be measured, and some of them are calculated. So, we're going to start with the idea of lung capacity. So, lung capacity is the maximum amount of air that the lungs can hold. So, the absolute most the lungs can ever have. It's a measure of the respiratory system's efficiency. The more you can air, typically the more efficient it is. And it is expressed in liters. So that's what the measurement we would use for that. So the first one is our tidal volume, abbreviated TV, and this is the amount of gas that's inspired or expired with each breath, which is normally about 500 milliliters. So when you're just sitting there and you're not even thinking about it and you're just breathing in and out, that's the tidal volume. That's just the normal in and out breath. The inspiratory reserve volume, IRV, is the maximum amount of additional air that can be inspired from the end of the normal inspiration. So you're breathing in and out like you normally would. So you breathe in your normal tidal volume inhalation, and then you bring in as much more air as you can. That would be that extra that you put in there is your inspiratory reserve volume. Expiratory reserve volume is going to be the same thing, ERV, except it's how much can you push out after that normal expiration. So you just breathe out like you normally would, and then you push as much more as you can out. The residual volume is the volume of air that's still in the lungs after you've pushed out everything you can. The reality is we cannot get all of the air out of our lungs. There's always going to be air that's still somewhere in the pathways, in the alveoli, there's something like that. This is not something that we can actually measure with our spirometer with the little gauge thing, and we'll use this, that we measure all these other volumes with. This is something that we just simply can't measure that. So then we have our total lung capacity we can actually calculate based on all of this information that we can measure and gather. So it's the volume of air contained in the lungs at the end of the maximal inspiration. And so we call it a capacity because it's basically all of the things added together. So total lung capacity is the RV, the IRV, the TV, and the ERV all added together. Our vital capacity, maximum volume air can be forcefully expelled following the maximal inspiration. So when we filled it as much as we can, and then we're going to push as much out as we can. And so this is also a capacity because we're doing a sum, it's calculated, a sum for the inspiratory reserve volume, the tidal volume, and the expiratory reserve volume. Anything that's a capacity, we're doing some calculations. So VC is the IRV plus the TV plus the ERV. That would be the same as saying we're doing the total lung capacity minus the reserve volume. Functional residual capacity, FRC, is the amount of air remaining in the lungs at the end of a normal expiration. So how much extra is still in the lungs after you've expelled what you normally would? It's a capacity because, once again, it's equal to the residual volume plus the expiratory reserve volume. So any of these things we can calculate are capacities. Inspiratory capacity is the maximum volume of air that can be inspired from the end expiratory position. So the idea here is we have pushed out as much as we can. So our lungs are as empty as we can possibly get them, and then we're going to draw in as much as we possibly can. So It really doesn't tell us as much information as some of the others, but so it's our tidal volume plus our IRV, inspiratory reserve volume. And then, of course, we have what we call dead space. The thing about dead space is, remember what I said, we can't get all of the air totally in our lungs or totally out of our lungs. There's always a portion of the respiratory system that's not involved in gas exchange. So we're not actually moving oxygen into the blood or carbon dioxide out of the blood. And so the idea here is that's considered dead space because there's air there, but we can't do anything with it because there's no exchange happening. So we can kind of break this into two separate things: anatomical dead space, which is like the airways, the nose, the mouth, the bronchi. These are things that hold a certain amount of air, but there's no exchange happening. And then alveolar dead space is actually alveoli is where the exchange typically happens. And so we have issues where sometimes there's a problem with the alveoli. It didn't get enough of the air to be able to do this exchange, or there may be something that's blocking the alveoli. And there's always some alveoli that aren't working correctly in your lungs. And so that would be your alveolar dead space. And then there are different types of diseases. We have restrictive diseases. These are things that are going to kind of restrict access. It makes it harder for air to move into the lungs, and so it's going to affect some of these volumes and capacities. Things like fibrosis, sarcoidosis, muscular disease, and chest wall deformities. And then we have obstructive diseases that are making it harder to get the air out of the lungs. So it's harder to actually exhale or get rid of this. So it's going to decrease our vital capacity, but it does increase some of the other amounts. And so emphysema, chronic bronchitis, asthma, these are things that it actually is making it harder to get the air out of the lungs.